So beginning Unit 2 with algebra for the topic, and don't let it get you down. Algebra's scary for some, but if you start to imagine, but I know you don't like the mix-up between numbers and letters, but just remember that those letters are just numbers we don't know yet. They really are just a number we don't know yet. So think about the number, the letter, is kind of like a number at a masquerade ball. It's holding up a mask over its face, so it's holding up an X instead of the 3 that it really is, kind of hiding behind it like a mask, and you've got to figure out, using some skills, what that number might actually be. Okay, so think about that. The letters really are just going to be numbers. And we call them variables, as another vocabulary word for us. When you see a letter, you can think this is a variable. This is something that represents a number we don't know yet. So the language of algebra, we can write expressions, which are kind of like sentences in algebra. And we can write them with variables. And again, variables being just a letter that represents a number we don't know yet. So some examples of these could be things like x plus 2. So this one's a pretty straightforward one to start with. X being a number we don't know, plus 2. So if we wanted to write out what that means in words, we would say a number plus 2. Or we could say a number with 2 added. Okay, so two ways to write that. They both kind of basically mean the exact same thing. And looking at another example, let's examine about 3n. So 3n is starting to get into a little bit of the tricky bits with algebra, and here we get what I call magic maths. So it's magical because really hidden inside of there is an invisible time sign. And we don't write the time sign, we leave it invisible just because, I don't know, we get tired of writing it over and over again, so this is kind of like a shortcut. When you don't have to write it, you don't. So what we're saying is that when you see a number and a letter, you'll have an invisible time sign in between them. So if we look at that again, we can say 3n, but really what we're meaning is 3 times n. And remember that n is just some number we don't know. So if I was going to write this out in words, I would say 3 times a number, because we're not sure what that is yet, right? So it's just 3 times a number. So another example for us to look at could be something like b over 4. Well, that's pretty, isn't it? Fractions and algebra. But remember, a fraction is just like a divide sign. It means the same thing. So we could also write that as b divided by 4. They mean exactly the same thing. Writing those two different ways mean exactly the same thing. And again, b is just a number we don't know. So what's going on here is b is being what? It's being divided by 4. So I would say a number we don't know, a number divided by 4. That's how I would put into words what I'm looking at here. b over 4, or b divided by 4, is just a number divided by 4. And we'll look at another one here. How about 2a minus 5? Okay, so one trick we've already learned so far. When you see a number and a letter written next to each other, what's the invisible sign that's going to be hidden inside of there? That's right, it's an invisible time sign in there, so don't forget about it. It's not just 2a, it's really saying 2 times a, take away 5. Okay, so we could write that out as 2 times a number take away 5. And there's another way we could write that too if we wanted to. Because remember, taking away 5 is kind of like saying it's going to be 5 less than whatever that was. So we could say 5 less than 2 times a number. So a couple of ways that you can put that into words, into language. And it's the same when you're writing a sentence. You can express the exact same meaning in a few different ways. So again, the algebraic expressions using the numbers and letters can be written in words, and you want to think about them in words to help you understand what's actually going on in the problem. So writing these expressions from the words, going the opposite direction we just did, is part of what we're going to look at next. So we'll look at a word problem or two. And we're going to start with a dog named Sparky, who has dog treats. She finds one more. So write an expression, a little sentence, for how many dog treats she has now. So she's got dog treats, and she finds one more, so that's just plus 1. Right? She's got a whole pile of dog treats. We don't know how many that is, but just a whole pile of them, right? She's got all these little treats in here. Some number, we don't know what it is, and she's found one more. So this is the big pile, and it is just the plus 1. Okay, so Sparky now has plus 1 dog treats. And looking at what she does with these, she is a generous dog and decides to share her dog treats evenly between herself and 2 other of her dog friends. So we need to write an expression to show how many dog treats they each get. So let's imagine the dog friends. We've got Sparky. We'll have her friend Lulu and her other friend Sophie. And they're all good dogs, and Sparky's got this big pile of dog treats. Remember, she had a big pile of but she found one more. So she's got plus 1 dog treats in a big pile, and she needs to figure out how to split it up evenly into 3 pieces. So think about what kind of maths that takes. To split something up would be to divide it by 3. But we need to make sure we divide the whole plus 1 by 3. So plus 1, we need to make sure we do the whole of plus 1, so I'm going to put it into brackets to represent the whole thing at once. And we need to divide it by 3. And another way we could write that if you want, this would be just fine, but keep in mind a fraction is just divide, so we could say plus 1 over 3. Either way would be correct, but that's how many dog treats each of these girls will get, Sparky, Lulu, and Sophie. So looking at another example, Sparky earns 2 times the dog treats as Lulu does. Lulu earns 1 more dog treat than Monster Ball, and Monster Ball earns T treats. Okay, so now we've got a lot of information. It's like overload. Let's try to simplify it a little bit. We know we've got Sparky, we know we've got Lulu, and we know we've got their friend Monster Ball. Okay, so write an expression, we're looking for a sentence again, to show how many treats Sparky gets, so she's the one we need to figure out, but we want it written in terms of T. And what that means is we want it to say something like 3 times t plus 5, or 4t plus 7. Okay, so t is in there as the variable, the thing we don't know. So what the heck do we know about t so far? Let's look back through the problem. Going backwards along, we notice that Monster Ball gets t treats. So we actually know how many treats Monster Ball gets. T. Again, that could be 50 or 5, we're not sure, but it represents it. It's a number we don't know yet. Monster Ball gets t treats. And working further back in time, through the problem, we know that Lulu earns 1 more treat than Monster Ball. So if Monster Ball gets t treats, Lulu is going to get t plus 1 more. And now moving further back through the sentence, we notice that Sparky gets 2 times the dog treats as Lulu. So we're going to say Sparky gets 2 times the dog treats that Lulu gets. And the reason I'm putting brackets around that again is because t plus 1 is everything that Lulu gets, so we need to make sure we times 2 to everything that Lulu gets, so we use the brackets. And because we can use our invisible maths here as well, you could also write this as 2 bracket t plus 1. Because there will still be a little tiny invisible time sign you won't write, but you'll know that it's there. Between any number and a bracket, there's a little invisible time sign. So both of those expressions would be correct, but you can write it without the time sign.